Welcome to the Bytecode, where we look at smart contracts with the people who wrote them. I'm your host, Shafu, and today's episode is with Devin. Devin, thanks for taking the time.
No worries. Yeah, pleasure to be here.
Awesome. Devin wrote this really interesting lens competition framework which is fully on chain. So he's going to walk us through it. So, Devin, please introduce yourself shortly, your project, and then walk us through the code.
Great. Yeah, thank you. Um, hi everyone. I am a serial shit poster on Twitter, but also a coder in smart contracts. I've been in the blockchain space since about 2017, and over the last 2 years, I've been working for myself, doing MEV, contributing to open source, mainly Foundry, for example, and most recently, I've joined Enzo Finance to contribute there on some of their back-end systems, including actually a transaction simulator that we just open sourced.
Mm,
But that's the quick version of me. But I love coding. Right now, mostly in Solidity, Rust, and before that, also TypeScript. I
nice.
should say, actually, the project that this is built for is Memester, which is the NFT meme platform built on Lens Protocol. And yeah, what we're going to show you today is the smart contracts that power the meme competitions that we run on Memester.
Awesome.
Yeah. Do you want me to
Yeah,
jump right into it?
let's do that. Let's do it.
Cool, cool. Um, I mean, I guess there'll be links to the GitHub. I always look at READMEs first, even though the docs might be the most boring part. I won't bring everyone through the README, but it's a pretty standard Foundry project. Already you'll see some things that WagMe, for example, does for us now, but if anyone looks at this script, they'll see that you could now use the new WagMe tools that was written before that. Um, but what I would say we do is we jump into the meat of it, and I'll also explain um, how Lens works as well as I go through it because that would be helpful.
Yeah.
I mean, maybe even first just to say that Lens is also a fully on-chain social graph. So it has primitives that we're going to see here, like posts or comments, which are actually also just a type of post, mirrors, which you could think of like retweets, collects, which are they're not exactly likes, they're a much more powerful version. They turn your post into an NFT. But what we did for this contract built on top of Lens is extended all of those methods so that you could kind of call them through our contract, almost like a proxy
Mm,
into the Lens contracts itself, and then you can use them in competition. So as a quick example, if you imagine a competition that you might see on Twitter or old school social medias, it would be like this post to enter, or the reply with the most likes wins. Of course, these can be quite gameable. We have other types of competitions as well, but that's what this framework allows. So it's kind of counting metrics on chain from Lens, whereas normally, of course, you would want to count them off chain.
mm,
So there's a bit more gas involved, but then you also have a fully on-chain settlable competition.
mm.
And just to say, before anyone says, bloating blockchain state with a bunch of social media posts doesn't make sense, the meat of the post goes off-chain on something like IPFS or Arweave, and also Lens has just released essentially a way of posting that only goes on data availability layers. That's out of scope for this today, but just to say that that's kind of how Lens works. Primarily, it's everything you expect from a social media, but Web3 format, so on-chain plus IPFS, all that goodness, and we built on top of that. So I'll just keep diving in. I might say, Shafu, at any point if you have questions, you can also just interrupt me.
Yeah.
We did build this as a upgradable proxy. I'm not the biggest fan of upgradable proxies personally, or on a philosophical level, but we had to do that because Lens itself is currently deployed as a proxy.
Mm,
And if they were to change the ABI for their contract, it would break our contracts. There's been cases of this happening in production for some large projects. So that's why we went with a proxy as well, just so that when or if there's any changes to the Lens contracts that we can safely change our contracts and upgrade them without needing to deploy new contracts. We did consider, I mean, maybe just to, I don't want to stay on this point too long, but generally I'm much more in favor of deploying new contracts with upgrades and letting people migrate as they want, leaving the old ones there. This is, of
Mm.
course, for example, the way Uniswap v1, 2, and 3 work. But in this case, we went with the proxy
Okay.
for the reason that we didn't want this contract itself to be bricked. Um, so that's what these are basically saying. So I'll start to highlight as I go through. So we're just using, you'll see my imports aren't resolving. That's just because I've got a fresh clone and opened it in VS Code. This isn't exactly the project structure that we used. When we're developing, I just cloned it again to make sure I don't have any personal stuff here. um, yeah, we use the OpenZeppelin essentially upgrade utils. So that's their clones, initializable, and their I'm forgetting what UUPS stands for, but I think it's unstructured upgradable proxy standard, if I'm not wrong. But it's essentially now I'm going to regret that I can't click in, but we can of course go in here. I don't have the submodules pulled. Okay, I'll come back to it.
Universal Upgradable Proxy Standard,
Thank you,
UUPS.
thank you. Yes, I appreciate that. Um, and yeah, so then we've built it with this, and I'll go through actually. I think one of the cool things in here is our deploy scripts, because it's kind of rare to see some proxy deployments using Foundry deploy scripts, so we can touch on that as well, about how we did that. I think actually the code ends up looking cleaner than it would in Hardhat, in Solidity. But let's maybe start diving into the meat of the contract. So at a high level, every competition that gets created has an ID. It's just automatically incremented on the creation of each competition, just going 1, 2, 3, 4, and all the way up. I think we do skip 0, which is the way everyone should do IDs on chain, because 0 is like an uninitialized state of uint 256. So in general, I recommend avoiding 0 as IDs. It will lead to more problems for you, I promise. So start your IDs at 1, which we do here. And then we also have this competition whitelist, which is, as you'll see again as we get into it, we have many different types of competitions, and they need to be whitelisted. So you can kind of think of this as like a modular approach, with this hub contract managing all of those different ones. That is currently behind governance. That's a safe multi-sig that the founders of Memester are behind. But if this was to take off, we would be very happy to hand it over to Lens governance, for example,
Okay.
which will hopefully become decentralized at some point. If you've looked at any kind of NFT contract, also this might look similar. I mean, I just mentioned that because NFT contracts are more popular than most, but it's pretty standard. We also have a competition count, just so that you can know at any point how many total competitions there are, and so we can get the latest ID that we need to use. We have access to the Lens hub. This is the entry point into the Lens protocol itself, which I'll touch on more in a minute. And we also have a governance address that's set. We're of course using the latest versions of Solidity, so we use custom errors rather than require strings. It reduces your bytecode size, it reduces revert gas cost by a little bit, and frankly I think it's just nicer. Because it's a proxy, we have an initialize function. We're using OpenZeppelin's initializer modifier here. So this is, you can kind of think of this as what your constructor would normally do, but very important that you do initialize your contract correctly. And here we just pass in the Lens hub and governance, and this is all orchestrated by our deploy script that we'll see. So up until now, we've just kind of been talking about the setup of the contract, but what we can do now is kind of take our first slice, and what I'll probably do is go just through all the contracts that are touched when you create a competition, because that's kind of, let's say, the main thing that you would actually do with this, and then of course entering into the competition as well. So we have obviously all of the Solidity docs being used, with some documentation here. Because I'm going to talk about it, I'll probably just skip to that so we can look at the actual function body. So I've got the whole function body in screen here. When you create a competition, you pass in a competition implementation. This seems very abstract, but this is exactly what I mentioned earlier about how we allow for different competition types. When I show you some competition types, it will make more sense. But this would be, for example, Whoever had the most collects on their competition entry wins, or it could go into much more. Yeah, it could go much kind of crazier. So even this competition implementation could decide, if there's one winner versus three winners, that's all down to the competition implementation. And they're not deployed as proxies, so anyone could actually deploy a competition implementation once it conforms to this interface.
Mm.
So any contract that conforms to this competition v1 interface can be a competition, as I said, and then once that's deployed, it can be passed into in here, provided of course it's in the whitelist, but we'll get to the logic in a second. The end timestamp is just how long the competition runs for, a day, a week, whatever you want, but that is the end timestamp, so the time it actually ends. And this is the first kind of lens specific thing that we see. So because, at least when we wrote this, I don't know if it's changed now, but because the core lens contracts were written in an older version of Solidity, and because they used Hardhat, although they've started using Foundry on some of their repos, we pulled in these contracts verbatim, which of course is not necessarily the best way to do it, especially because there can be compile differences, but we have a ton of tests and we were happy to do it this way. We only really needed 2 contracts from Lens, so pulling it all in, making it work as a Foundry submodule, and upgrade, deploying it ourselves on our tests and everything, was just messier than honestly pulling in these 2. One's a library, and one is an interface, and that's all we needed. I generally don't recommend this, but we really pulled in the full Lens core, and it just caused more problems than copying these. Again, if they change anything, we will also and then deploy and upgrade. But let's look at. Sorry, I'm going to keep all these open. Let's look at the first one that we've encountered here. I would normally command click, but I don't know if that's working. Let's just see if it is, because I didn't set the project up fully. But this is essentially the post data for any post on Lens. So I won't go into again so much detail on these different data types because it is Lens specific. But when you make a post on Lens, you of course tie it to the profile ID of the person who posted it. The content URI is actually all the metadata and all the data of the post itself, so the content, any images, that's all put on IPFS. You could think of this very similar to, again, how NFTs work, where they have all their actual bulky content off-chain. That's exactly how Lens works as well. And then we have some modules and some module init data that I'm gonna say is out of scope for today. But it's basically who posted it and what the content is. And what we do in the Lens Competition Hub, our contract, is we take that post data and we actually call the Lens Hub and post it with their signature. So I was showing you the post data. Really, we do use the post with sig data, which is essentially a way of posting on behalf of someone else. This means we can avoid 2 on-chain transactions. So what the user experience for this is that you create a competition on Memester, and anyone can actually do this today if you have a Lens profile, and it's one signature pop-up and then one on-chain transaction, which is really nice that Lens itself actually has this. And what it basically is the same data that we saw, but with a signature appended at the end. So we can just get this from their user's wallet and then append it so we can basically post on their behalf. That's what this is doing. Or even so that they can post on their own behalf. That sounds a bit weird, but it basically means that if you're creating a competition, once you have a post, this is kind of doing the checks that person wants to make the competition. This means in the future we could make a gas list, we could pay on behalf of them, and again it avoids 2 transactions. So from this point on, we do just call straight into the Lens Hub, as I mentioned. A lot of stuff happens in here, but the Lens Hub contract just returns the publication ID, and then we also need that later on, as we'll see. And that is then the post on Lens. So from that point on, that post will be on Lens. Lens's own indexers will pick it up. Anyone who has integrated with Lens will be able to see this publication. Of course, once everything finishes, it's all atomic. But it's really nice the way, just to mention again, the lens contracts are written that we can just do this, and then we can do all of our competition business logic below it.
Mm.
Um, so at this point, we just make sure also that the competition they want to create is whitelisted, and we increase the competition count, and then and also store that in a local competition ID variable, which we're also going to return. We do quite a bit here that I'll explain, but all of this is essentially deploying the user's competition. So each competition is its own on-chain contract, and that
Mm.
was important to us because it makes it more flexible in our opinion, because then once it conforms to this interface, we can whitelist new ones in the future. We think it's a nice on-chain separation as well, and it means that we don't need to have a ton of state in one contract. So what we do is we use the clones from OpenZeppelin, which is essentially a very lightweight proxy, you can think of it, although it's a proxy without any upgrading. But all that will do is deploy a very small amount of bytecode that essentially forwards on any calls using delegate call, of course, to this competition implementation.
Mm.
We use this, we do generate a salt, so this uses create 2 under the hood, if I remember correctly, because we wanted to make sure that the address of the competition was deterministic when it was deployed, and B, that it depended on the message sender as well. So this is to avoid essentially people trying to deploy 2 of the same contract at different, or yeah, essentially trying to race each other for a certain competition address. Essentially now they can't, because if we use just create, it would also depend on the calling contract, but here it only depends on the data that essentially is being used for the competition while taking in msg.sender. So this means that if I'm actually trying to think back on this right now, but the reason was, if you, let's say, make 2 competitions, we can basically know what address it's going to have, and that's helpful for our front end, so that we can redirect them to it and start to use it before it's even landed on chain. So
Okay.
this is a create 2 clone basically.
Yeah.
And then because it's a clone, which again is like a form of a proxy, we need to initialize it rather than passing in anything in the constructor. So we do that, and then we also add it to the mapping that I mentioned up above. So that's the mapping of competition ID to the competition instance, essentially, just using the interface. And then we emit an event, just with all the details that again our front end needs, so that we can just use events to index everything. Although I do think we have a small backend component because it just made it neater on our front end. But yeah, this is just for any other future API integration as well. It makes it neater to have all this stuff in an event. I know some people will say I'm also bloating chain state here, but events are just neater than trying to trace every transaction.
Yeah, Devin, I have a couple of questions here.
Yes, yeah, go for it, go for it.
So the first thing is the revert competition not whitelisted.
Hmm.
This seems like it would fail quicker than the post with the sig function. I'm not. I don't
Hmm.
know how the post with sig is implemented, but would it make sense gas-wise to put the thing that fails quicker first?
Yeah, yeah, you are right. It probably could. Yeah, yeah. I mean, I guess it's nice that it's a proxy, so we could upgrade it for gas efficiency. Um, I should also say maybe a few things now, which is that this hasn't been audited, and we would love
Hmm.
to do an audit for it, but we are self-funding Memester, and hopefully we can eventually get an audit for it. We are trying to organize one at the moment, um, but we are just fully funded with grants from Memester. The other thing is we don't have any, because we don't have an audit yet. real form of money that's used in this yet either. So when I
Mm.
talk about the different competition types, we'll see some that have prizes, which can be on-chain ERC20 or ERC721 tokens, and they're not enabled yet actually for that reason. So once we do get it audited and we find anything like this, um, we will be able to enable those. But I think you're correct. Yeah, I mean, because this could revert quicker, there is a lot that happens in here too. So I mean, if you send it with the wrong signature or with the wrong nonce, for example, because it's possible that maybe you post elsewhere before this lands on chain, this could also revert.
Yeah.
Um, I mean, I guess the question is like, what's the most likely place for it to revert? Yeah, I mean, I guess even just because this is a smaller check, it should probably happen first, actually. Yeah, so that's a
Mm.
good point. So thank you. This is a good code review.
The second point is a more philosophical software engineering point.
Hmm.
But what do you think about putting stuff into a contract that makes life off-chain easier? So you said, for example, that the clone deterministic create two part is something that makes your life on the front end easier. So I'm asking because personally I'm at a point where I don't put anything in the contract uh, that isn't necessary for the contract. You know what I mean?
Hmm. Hmm.
What do you think
Yeah.
about that?
Yeah, I mean, to be fair, that's one part of it. The other part is that we wanted the contract address to depend on the MSG.sender. To be very honest, I'm not sure if there was a potential vulnerability here, and that's why we did that.
Mm,
I I want to say that there was, but I can't think of it right now. So I also don't want to speak lies. But in general, I think, yeah, I mean, we should treat chain state carefully, even though here we're not. Lens is on Polygon for exactly that reason too, because if you've been following Polygon, Lens has consistently been like one of the top gas guzzlers, and that's why they're also
mm,
moving more stuff off chain. I think for something like competitions that can have ERC20 prizes, it's nice to have that on chain. Um, but even like with the event, it's another good point. I will say though, I do like a dedicated contract that might have some view methods which can make the front end's life easier.
yeah.
Um, but also that also doesn't even need to be deployed. So I am well aware of how you can do a state override with ETH call and then essentially just make it look like it's deployed to your local node. And I also back that. Um, but I don't know. I guess it's a middle ground, right? Because ultimately these contracts are going to be used by just more than other contracts. The way
Mm.
99.9% of people will interact with it is a front end. So I think it's a delicate balance. I mean, if we purely cared about chain state, we would try and write everything in assembly, and I think our speed of innovation would be a lot lower,
That's
right?
true.
And
That's true. That's true.
yeah, so it's a delicate balance. But
That's a
yeah,
good
maybe we
point.
went a little bit over here because it's on Polygon.
Okay. Okay. Okay.
Yeah, but great question. Yeah,
Cool. Yeah, let's continue.
cool, cool. Um, I mean, also for the sake of getting to submit, I might not go through all of the kind of different ways you can enter and interact with one, but I'll go through at least entering, of course, that's an important one. But then we move to some that are kind of similar that I might skip over quickly. But um, let's look at entering a competition. So entering a competition, the way it's structured on the Lens side, is that your competition itself is a post. So that is like a top level publication. You can think of it in the Lens social graph. Like a post by itself has no parent when it's the main post, and that is the competition itself. And then the entries into the competition are comments on that post. So on Lens, they actually also look very nice, which we thought was pretty cool because to other front ends, the competition is like a post that I made, and then the entries are replies to my post. So
Hmm.
actually on Lenster or on Favor or any of the other front ends, the competitions actually look really nice because it says, hey, this is a competition that's going on, and then in the replies you see the entries into the competition. Of course, on Memester we can even format it nicer again because we know these are competition entries. But to other front ends, which is very important for Lens, it also looks quite nice in that it's not just different posts that aren't connected anywhere on the Lens social graph. They're also connected on the Lens social graph and on our contract.
Hmm.
Yeah. So that was so. Of course, not every comment on a competition publication will be an entry,
Mm.
but every entry will be a comment. So you could also just kind of leave a general comment and say, "Oh wow, this is a cool competition," but right below that could be a comment which is an actual entry into the competition.
Okay,
Yeah.
okay,
I know that's a
okay.
lot, but if you if you go onto the Memester competitions and then you look at them also on Leinster, you'll see exactly what I mean, which is that
No,
without us needing to do anything on Leinster, they also look nice there.
that's really cool. Yeah,
Yeah.
you just have to parse it correctly on the front end. But on
Yeah.
Leinster, there is no difference between an entry and a comment. It's the
Exactly.
same thing.
Exactly. Yes. And then they could very easily check if it is an entry if they
Mm.
integrate. So
Okay.
hopefully. But yeah, so that's how it's structured for Lens. So we pull in their comment with sig data, which I won't go into. It's basically just very similar to the post with sig data, but it references a parent publication, which would be the publication ID that we got here. So now that's basically how they're all linked on Lens. And of course, it has the signature data. So again, it's signed the by the person with the lens profile, and that's all checked for us in here. And then you also need to pass in the competition ID to say what competition you're entering. And on this one, I did skip over actually this competition init data. Maybe I shouldn't have. So bear with me for going back here. But this is arbitrary bytes, which a specific type of competition might want to do something with. And I can show an example of that. But it again, just because we have this kind of modular style of competitions where we don't know what type of competitions might be built in the future, we pass along the stuff that we think the competition might want. That every competition will want. But we also pass along these arbitrary bytes, which can be used by the competition in different ways in the future.
Mm.
And they can be ABI encoded and decoded. I'll show an example of that. But we do the same thing here. And actually, I think we do the same thing in every function, which is just that if in the future, like I said, there's some extra data that we want to send to the competition that we don't send, through the standard, let's say enter or create function, we can pass it there. So that's what this is for.
Okay.
Um, so yeah, so we get the competition instance from the mapping based on their competition ID. We get what we've called the creation profile ID and the creation pub ID. This is essentially getting the profile ID that would have created this post and the pub ID. So on Lens, every type of post is denoted by the profile ID and the pub ID, and they're two integers. But it's basically like saying Devin's profile ID, and then Devin's first post, and then Devin's profile ID again, and Devin's second post. So the pub ID is just incrementing every time I post on Lens, and my profile ID stays the same.
Mm.
But it's not. My point with this is that the pub ID is not, unique to the whole Lens ecosystem. It's actually the combination of my profile ID and my pub ID that then gives you a unique Lens publication. Because if you've just created your first Lens publication, your profile ID will of course be whatever profile ID you were assigned, but then the pub ID would be 1, and then your next one will be 2 and 3 and so on.
Mm.
So basically, to fully qualify what Lens post you're talking about, you need both. I don't know if Lens has actually come up with a great term for this. I think they should. Maybe I'm wrong. Maybe someone can let us know if they have by now. But previously you had kind of your own pub ID, but then the combination of them was also called a publication ID. So I think we need to come up with something that's like a fully qualified pub ID or something. But anyway,
Mm.
this basically just means we know exactly the post that was the um, that was the Lens competition itself. And if this is a bit crazy, but basically, if you've commented on a different post than the one which was created when the competition was created, we revert. Because what that would mean is that you could enter a competition while commenting on someone else's random Lens post. So we need to make sure that the comment that you're putting into Lens is commenting on the correct post where the competition is actually being hosted.
Mm.
Because that would be like, let's say I tweeted a competition and you, Shafu, had another random tweet, maybe about this talk, and then someone entered my competition under your post. So they would be linked on our contract, but they wouldn't be linked on Lens. So that's what we're basically checking here. That's what all of this is.
Mm. Okay.
Yeah.
Okay.
Because we can't really trust that, you know, this won't check at all. This is Lens is like, yeah, you're commenting on this post, that's fine, but we need to make sure that you've commented on the correct post. This is something that we
Mm.
also maybe could have put up further in the check actually, because this is
Mm.
much more gas intensive part.
Yeah. True.
Um, and then at that point there we're satisfied because again just to say this does quite a lot. It's out of scope for today, but this checks your signature. This makes sure that you can comment on it and everything. And then once that's all satisfied, we say that you've entered the competition, and we actually call the competition instance. And they can do what they want with that. So they could, we'll go into again an example of it now, but they can track different things, and we emit an event again. So that is kind of the enter flow.
Okay, maybe just to summarize the
Yep.
last part, basically you have the lens abstraction and you have the competition abstraction, and here you need to make sure that you're basically connected correctly.
Yes,
Uh,
correct. Yeah.
Okay,
Yeah,
okay,
exactly.
cool.
Yeah, because they don't check each other otherwise. Yeah,
Yeah.
the lens abstraction isn't aware of the competitions. Yeah.
Mm.
Yeah. Um, and I think I'll skip over these in the name of time. I'll invite people to look at them, but these are different things you can then do with a competition entry. So if I host a meme competition, I would of course run the create competition. Then let's say you Shafu maybe make a meme that would call this function, and then maybe we've said that the winner of the competition is determined by the entry with the most collects. And again, collects are a lens thing. You can kind of think of them like likes. They're much more powerful than likes. Um, but then if someone maybe collects your entry, they also need to call this. So um, yeah, to go over this quickly, it's essentially proxying all the actions again that can be done against your entry, going through our contract so that we can count them. So this is being able to do things on chain like counting how many collects you've got, or how many retweets, for example, or how many likes you've got on your meme that you entered into the competition. And just to say again, I'm using memes as an example because that's what we built obviously for Memester, but it could be just a single small joke competition. It could be a video entry because Lens also support videos. It could be, a photography competition, anything. And these are all supported the exact same way
Mm.
as meme competitions are. Um, and yeah, so we just go on. You can also mirror competition entries. So again, you could have a competition that's decided based on who gets the most mirrors on their entry. And then the final interesting one here is just ending a competition. Um, because blockchains can't do actions by themselves. Um, Even when the end timestamp has passed and the competition is over, you need to actually finish it, or mark it as completed. Um, Obviously, the important thing with this is that if you've created a competition which, for example, is just I'm going to judge the winner. I'm going to pick the winner. So whoever creates the competition decides the winner. Then you would also need to pass in who won, for example. But this is just left open, at least on this layer, as quite a generic concept of ending the competition. So it could also in future be called by anyone. For example, an off-chain bot that we run, just to kind of constantly go through and end competitions for people.
Mm.
And we've thought about incentivizing this with like a small little fee for bots to run. But that's something we could also do in the future.
Cool.
Yeah, I won't go over the other stuff. This is actually determining the competition address. So there's some more code on chain that that helps us know where the contract's going to be deployed. That could definitely be another contract. Um, but yeah, it's just a pure helper function. And then some governance functions for whitelisting, changing, and doing the upgrade.
Okay.
Yeah, and actually another view function here, just to get the winners, just to make it a bit easier than doing like a multi-call that's built up. don't get me wrong. As a smart contract dev, I'm all for making these smaller, but I also did code the front end for Memester.
Okay.
I was full stack on this, so I was helping myself. Yeah,
Okay, okay, okay.
yeah,
Yeah, I do that too sometimes. So
yeah, yeah,
I know I know what you're going to through.
yeah, yeah. So,
Yeah, go
or
ahead.
if you don't have a question, what I could maybe do is actually dig into, because I mean, what we've kind of just done is look at the surface level, what you can do with the competitions, but I could look at a competition type now itself, and we could see kind of how these competitions really work.
Yeah, perfect. Let's do a competition type and look at the deployments at the end. I really want to look at the deployment
Yes,
script.
perfect. Yeah, we'll do. So let's take our most simple competition type for now. This is one that has no on-chain prizes and just has a single judge. So it's just dictator competition style. um, and yeah, I mean, just again to say, we have some that have prizes. We have tests for all of this, like quite a lot of tests. I'll just scroll down just so people know that we do test our code
Mm.
pretty rigorously. But we still won't whitelist the prize competitions until we have an audit. It just feels
Okay.
wrong to accept ERC20 tokens or ERC721 tokens in any contract without an audit. So at the moment, it's purely Pride on chain that you get, but of course, the people we've been working with to host some big competitions, they're giving competitions off chain. Yes, it's not
Mm.
the promise of the contracts, but it's we feel better about that for now, and hopefully we can enable them soon. So anyway, without further ado, let's look at a competition. So this is like I said, a judge competition. Yeah, we probably could have put in some docs here to explain more what they are. I like that everything just went red again, just to say it's because I opened a new VS Code window. But maybe just to quickly say, while we have this competition v1 interface, I'm not going to go into so much detail on this because we're going to see it in action, but we do also have a base competition v1, which just gives us a ton of helpers that go into these contracts, and then we inherit from that again. If there's any Viper people that are watching this, they're probably screaming because they don't like inheritance. Frankly, I think it made our actual contracts for the competitions nice and neat, because we had some common things between all four of them. Um, I'm not going to go into that now again, just in the interest of time. But that's just to explain why we don't necessarily have competition v1 here. That's being inherited further down the chain.
Mm.
Um, okay, so when a judge competition is created, which would be called right here. This is exactly it. In the Lens competition hub, create competition, competition.initialize. We jump in here, and we get the profile ID, the pub ID. So this is like again your fully qualified Lens ID of that post. We ignore, I think, the sender. Yes. And we get the end timestamp and then any init data. So you're going to see an example of this init data, which is arbitrary bytes again. So that allows us to have specific parameters for each competition. We do a few things just to make sure that this is only being called by the competition hub. This could have also been a modifier, but when we're using custom errors, I do like actually having it here. But anyway, that's more of a code style thing. We then set, yeah, I mean maybe now that I'm explaining it, people that are against inheritance will laugh at me. But every competition has a creation profile ID and a creation pub ID. So we just set them. Every competition also has an end timestamp, so we set that. And then we actually get the competition specific init data. So in the case of the judge competition, this would actually hold the address of the judge, because we wanted it to be possible that anyone can make a competition but assign another address to be the judge. So that could
Mm.
technically be a multi-sig actually, which would make it maybe, or it could be a DAO, for example. It could actually be
Mm.
a full DAO contract on chain that's a judge for a competition. So yeah, maybe we're thinking pretty big, but we like to think in terms of blockchain primitives. And just to say, this is just decoding a very simple struct that contains the address of the judge. So again, just to say, the judge can be a different address than the person creating the competition is. That's all that does there.
Okay, why make it a struct then?
rather than just address.
Yeah.
Yeah, that is going to lead to. Well, I'm actually trying to think if this gets just encoded nicely. I didn't look at the raw ABI myself. The reason we did it was to have kind of um, a nice pattern in competitions that have more data.
Hmm.
Um, I would like to think that that gets. I don't know if you know the answer to this. Does that get converted down into like a pure address just by just like a uint 160? I don't think so.
Like the struct with one field?
Yeah,
Uh,
it doesn't, right?
That's a good question.
I don't think it does. So yeah, we're wasting some bytes there. That's true. But yeah. I guess we are definitely wasting a bit. But it is call data. It's never been put into memory. Also, you have to pay for call data, so on L2s will be a bit more. Anyway,
Hmm.
Polygon isn't one. I'm gonna rage some people with that. So, but it works nicer here, for example, when you might have a lot of data in there. So we just wanted to keep the same yeah pattern essentially.
Okay.
Yeah, for more complex ones. Yeah, but we definitely could have just done address. I actually
Hmm.
don't know if that'll work, but again, like I said, I don't have the full IDE working here. Um, but good question. Um, so what I'll do then is just kind of go over enter as well. So of course, when you enter a competition, we just check that, or sorry, we set that you've now entered, which we check later on in some places, and we make sure, of course, that the competition isn't over. So that's if there's a winner being selected, or if the timestamp is greater than the time it's supposed to be over. And what was the other thing I was going to say here? Yeah, I mean, so in the judge competition, it's very basic because all we're actually doing is just saying that this profile ID with this pub ID entered into this competition, so that later on, if they're being selected as a winner, of course you can't select someone that hasn't entered into the competition.
Hmm.
Um, in the judge competition, collected, mirrored, they don't do anything because they're not used. Again, it's just used purely as yeah, purely just a judge deciding who won. So when it's ended, when the competition has been ended, so this would be called from end competition here in the hub. Everything goes through the hub again, just for that layer of abstraction. So once it's been yeah told to end, we make sure that again it hasn't already a winner hasn't been selected. This end data is also passed in as bytes, but it's also a struct with the winner. So this is essentially the winner that the judge selected in the profile ID and pub ID again. So I know that's everywhere in Lens code. You'll see that a lot. And then we ABI decode the data that they sent in. And again, the reason for this being bytes is just to say that different competitions might do something else at the end. They might choose a winner a different way rather than just a judge. And then we check some things that again, yeah, we could maybe do in a different order. um, and yeah, make sure, for example, making sure that they're the judge, they're allowed to do this, the competition's not still ongoing, that they have actually entered. And then if once that's all fine, we set the end data and also set this looks like a duplication. It's because we kind of need it in different places, but we actually have this concept of essentially an array of winners. And while there's only one winner here, it was so that in the future we'd be able to support multiple winners. If we look here in the judge competition with multiple winners, we can see that actually the end data is just this array. It's a bit messier here, and I know I generally don't like arrays on chain, but the thinking here was that at max we're probably going to have like 3 winners, and it's just going to be in order of what they of first, second, third, for example, in 0, 1, 2. So it's not
Okay.
that much, and it meant that yeah, we can be returned nicely to the front end and potentially to other contracts. So I went a bit quicker at the end because I do want to get the deploy scripts in, and
Yes.
I can go a
Yes.
little bit beyond anyway, Shafu. So because I do want to get the deploy scripts in, but I think I don't know if you've any questions overall on that structure of the hub and the modular competitions.
Not really.
Cool.
Yeah. Let's jump into the deploy
Yeah.
scripts.
Yeah, so I'm a big fan of writing deploy scripts that are testable as well. So these deploy scripts are also run in our tests directly. So our tests don't have any kind of specific setup functions. I mean, they do, but they basically just call these deploy scripts. This deploy script is using, of course, Foundry scripts or Forge scripts, and I'll run through everything. But one thing just to say that you might notice from most Foundry scripts is we return a struct with the contracts that have been deployed, and I think everyone should do this because this is kind of the key to making your scripts testable,
Hmm.
which is it's not used when we invoke Forge script from the command line. You don't use this at all. But what this allows you to do is A, chain together multiple scripts if they depend on addresses from a previous one, and B, it allows you to test them. And I'm going to show that now. But let's just high level go over what this is doing. So we're instantiating the Lens Hub contract based on your an environment variable called Lens Hub. We instantiate a governance address based on your env with the governance key. We get a deployer. I'm kind of going over the boring parts a bit quicker. This is whoever's deploying the contracts. And then we use the Foundry cheat code to start broadcasting. So from this point on, contract calls that would result in an on-chain transaction get deployed. That's basically what this means. So we first of all deploy our competition hub. That's the kind of main contract that we went through today. And then we deploy a ERC1967 proxy using that competition hub implementation. This is essentially how you do a proxy contract in Foundry. Yes, if you've used OpenZeppelin's nice JavaScript libraries, this might look a bit dirtier, but if you're a Solidity engineer, I think this is going to look as clean as it gets because it's very clear we're deploying a proxy that uses this address as the implementation, and this is what's getting passed in to the initialize function. Well,
Hmm.
actually, it's the bytes that are being sent to it. So we even have what this is basically saying is call the initialize function and pass in lens hub and governance, and this all happens in one on-chain transaction.
Hmm.
And then we end up with our competition hub as a proxy. So we just cast that to the Lens competition hub contract type, which means that from then on, we have this contracts.lens competition hub um, contract instance, which is, just to be clear again, this will point to our proxy, and our proxy will point to the implementation, of course, delegate calling. But then the reason we just wrap it in this Lens competition hub is so that the Solidity compiler knows it's of type Lens competition hub, and you can call it as such, including the functions um, that are in the competition hub. Um, then we just deploy the judge competition and the judge competition multiple winners. They're the two that we support right now on Polygon mainnet. Um, and we again, this probably looks a bit weird. It's for people who haven't done this before, but what we're doing each time is we're just saving the address that we get into this struct. This
Yeah.
struct called script returns deploy one. And this is not that one. This is a pattern that yeah I'm trying to promote. But essentially, what you're doing is you're just saving all of your addresses that you might need in tests or in subsequent deploy scripts into a struct. And we're just kind of doing that all in one line. I mean, you could split this over two lines and then you could assign it,
Hmm.
but it's just setting it there. Yeah, I think you're starting to see where this goes because then what it
Hmm.
means is in your tests, again, yeah, I'm a sucker for inheritance. You can tell that one of the first languages I got really into is Java. um, uh,
Me too, actually. That's funny.
yeah.
Yeah, yeah.
um, then in our tests, there's quite a lot here, but the juicy part is this. So yeah, we set up a lot. We fork Polygon. We get the relevant addresses again that we're going to need later. We label some test users, but this means that when we run our deploy script on mainnet for real and actually deploy our contracts, we've also tested our deploy script because every time we run
Hmm.
a test, it gets run. I think that's really powerful. So then you don't have a setup script in your tests that's different to your deploy script. It's the same Solidity code that's run, which results in the same transactions being run. And then you can just kind of write your tests as you normally would. There's a lot of boilerplate here because in our tests we have the second set of contracts where we deploy those competitions that haven't yet been deployed on mainnet, like the ones with prizes that we wait on an audit for. Um, and then you just have all your contract instances that you need for your tests. We whitelist them by pranking governance. This is a Lens thing just to make sure that we prank the Lens profile creator, which is currently a address on Polygon mainnet that's allowed to create Lens profiles because it's still also behind a whitelist. And we create some Lens profiles so that we can have accounts on our forked test network that have Lens profiles, because of course otherwise none of this would work, because later on in those in the contracts they of course try to post or interact with Lens, so everyone needs to have a profile. And then this was before I found out about the deal cheat code or the deal helper in some of the Forge standard library, so you don't need to do this anymore. Ignore this part, but we're just getting everyone some Rapmatic. Yeah, so I mean, while this is quite big, it would almost be nice to just kind of show people this part. This is the important part. Please, please, please start doing this. And if someone has a reason why we shouldn't do this, let me know. But I think this is really powerful, and it's probably one of the main takeaways I would have for people. And then in your tests, you can just access them. I know because of inheritance, this might look a bit weird, but basically all these contracts, which are the contracts we're trying to test, are available in all of the tests. And again, they're from the deploy script.
That's really clean, Devin. I really
Yeah,
like that.
thank you, thank you. Yeah, it helps. You feel more confident then when you run your deploy script for real.
Yeah, and the thing about deploy scripts is it's really funny. Like most audits don't look at the deploy scripts, which is
So true,
sad, but
so true.
true.
Yeah, yeah, you're right, and that's where a lot of things can go wrong.
Yes,
Yeah,
yes.
that's a good point. So hopefully now then, if we got this audited, they would see it if they look at the
Mm.
tests.
Yeah, 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 for sure. Yeah, and most deploy scripts are not audited and not even tested.
I know,
So
I know.
this is really good.
Yeah, thank you, thank you.
Yeah.
I don't know if I know I sped up a bit there, Shafu, and I apologize. It is just unfortunately I don't have so much time, but I can stay a bit longer if there's any specific questions you had, because I don't want to leave something.
Not particularly about the code, but maybe just one question because I find it interesting. So first of all, thank you for the walkthrough. Really, really well written code. You did a
Thank
really
you.
good job at presenting this. So yeah, thank you for that.
I appreciate it. I should
Um,
quickly say it wasn't just me.
okay,
My partner in crime, Ape Dev, also he's acknowledged in the code as well. So it was a team effort. But
okay,
yes, you're very welcome, and it's been a pleasure.
awesome. Shout out to Ape Dev then.
Yes, yeah.
But Ape Dev sounds like a Viper programmer, by the way. But
Yeah, yeah.
but okay, he writes Solidity too, which is good.
Yes.
Yeah, general question about Lens.
Yep.
I like the idea, but currently I don't see a path towards full decentralization, right? So, for example, the whitelisting of profiles. Is there? I don't think there is a date where they totally open it to anyone. Is there?
Not that I'm aware of, but
Okay.
I would imagine they will.
Okay.
From what we've been told and what people know, it's that if they I think Stanny has even said this, but if they didn't have a whitelist, with the kind of traction they've got, Polygon would constantly be like be used by Lens, and I really think so
Hmm.
because it's really
Hmm.
constantly a top three gas guzzler. So I think they're doing that while they explore scaling solutions, and they did just release one. And Josh from Aave and Lens is going to hate me that I forgot the name of this one that he worked on, but I'll see if I can find it in the background. But they're working on some other scaling solutions, and I think then they'll open it up.
Okay, so you think the main reason is that Polygon would just get swamped with lens transactions. That's interesting. Okay.
I mean, look, I think that's part of it. I also think Lens and Ave are very good at marketing. And,
Hmm.
by having a whitelist, let's just be honest, you create a bit of FOMO, right? People want in.
Hmm.
And that's always good for getting awareness and some good marketing towards your project. So I think it's a bit of both. But yeah, I know that they're reluctant to do it until it can scale a bit better. And just to say, the project they're working on is called Momoka,
Momoka.
which is one way they're thinking of scaling Lens. If people want to look into that.
Okay, yeah, send me the link. I will put it into the description
Cool, cool.
for anyone that's interested. Awesome, Devin. Then thank you for taking the time.
No worries. Thanks for
Uh,
having me.
yeah, for sure. If people want to find you, what's the best place?
I would say Twitter, and my username is just devanoneth, all
Okay,
one word.
so just by the way, Devin's Twitter is really great. Look him up. He's a great follow in the Solidity crypto EVM space. I think you're an EVM guy, right?
Yeah, pretty much. I looked
Okay.
at other chains a while ago in my time since 2017, but nothing has caught my eye as much as yeah the whole EVM ecosystem.
Okay. Yeah, same here, same here.
Yeah.
Okay, awesome. Then thank you guys for tuning in, and I will see you in the next episode.
Thank you,
But
Shafu. Appreciate it.
yeah, for sure. Bye. Bye,
Bye bye.
guys.